Honors Algebra 2, Chapter 4 and 5. So I'm switching up the order in these two chapters. We're actually going to do 5.1, 5.3 first. This is just exponent rules and then polynomial operation. Reviewing these exponent rules, we should realize how to write exponents without power. So basic one, 7 to the third is how we say that, and that's just 7 times 7 times 7. 5n squared, we've talked a little bit about this at the beginning, is that this square goes to everything it touches. It touches the parenthesis, so it goes to the 5 and the n. So you have 5n squared, so you have 5n times 5n, you have two of them. Writing with exponents, this would be 2 and then x, and then we have 4 x's here, so it's x to the fourth. So here we have a 6 squared, we have an a squared, and we have a b cubed, which we could also write in parentheses 6a, that quantity squared, times b cubed. So we can pull that square out a little bit. So we could also write this as 2 to the 7th, because we have 7 2's here being multiplied together. Similarly, we could do that with variables. X to the third, x cubed, is x times x times x. X to the fifth is 5x's being multiplied together. So if we rewrite this, x to the, how many x's do we have down here, is 8. Now a faster way of doing this problem is using exponent rules, where we have 3 plus 5 is 8 and 4 plus 3 is 7. So that's telling us how many we're actually multiplying together. So that's called the product of powers property, where b to the m times b to the n is equal to b to the plus m plus n power. Some practice problems here. This would be the same thing as -4 to the 3 plus 6 ninth power. And you can evaluate that with a calculator, but that's another way of writing that. This one would be w to the, this right here is w to the first. So then if you add them to the 11th power, w to the 11th. This was a little different. Now we have a power and we have another power sharing the same base. Prior to that, these powers here, they've each had a base of w. The new problem here, the exponents are sharing the base. So this right here is really saying we have a 5 squared, and we have that 5 squared 3 times. So we have 5 squared and another 5 squared, which, using the rule we just talked about, these all have the same base, and so we can add the exponents. So it's really 2 plus 2 plus 2, or 6. 5 to the 6th power. Faster way of doing that is using the rule where we actually multiply these. And so I think about how if the exponents here share the same base, I'm going to multiply their exponents. If they each have their own base, then I'm actually going to add them, and that's kind of the difference here. Here, d to the 4th to the 5th power is d to the 20th, and multiply there. This 3 goes to the different things inside the parenthesis. We have a 6 times p squared. So this is really going to be the same thing as 6 to the 3rd power times p squared to the 3rd power. So that power of 3 goes to both of those, which 6 cubed times p to the, and we can multiply these to simplify it, to the 6th power. Next one, power of a product. If I have two things multiplied together and I have the power of n, so when we just talked about, the power of n goes to both things in there. Another example here for you to follow, and you can evaluate the 3 to the 4th is 81. Here, this 4 goes to both the -2 and the x. So we have to be careful here, a -2 to the 4th and an x to the 4th. -2 to the 4th will actually come positive, and it's 2, 4, 8, 16. X to the 4th. Here, this 2 goes to everything inside here, the different terms, the different, actually it's one term, the different variables or products, each one of them. It does not go to the -2 in front, and we have to follow the order of operations. We have to do the parentheses, and then we have to do the power. This is really 3 squared, x cubed squared, so I'm going to break it up in smaller steps. So this is the same thing as -2, and we have 9, 3 squared is 9, times x to the, multiply these, 6, and then we still have m squared. Now we can multiply this by the -2, and we're just doing -2 times 9 is really all we're doing there to get the -18 x to the 6 m squared. And so this is being cut in half. You look at pattern 16, 8, 4, 2, 1. So we continue that pattern on, we should have 1/2 and 1/4. So this kind of helps us with this rule here of negative exponents. And so the powers are getting cut in half, as we move down. So here's a negative exponent property. Anything to a negative power can be written as 1 over that power with a positive exponent. And this could, I kind of think about how the negative exponents just means it's in the wrong spot. So right now it's in the numerator. If I move it to the denominator, it just becomes positive. It doesn't mean anything's negative. It's a notation saying we're really dividing by that, or you can move it to the other numerator denominator spot. So x to the negative fourth is the same thing as 1 over x to the fourth. Let me do another example. If it starts in the denominator, if we had the same problem, 1 over x to the negative fourth, I can rewrite that by moving that negative exponent to the top, to the numerator. And so that's the same thing as x to the fourth. So 2 to the negative fifth, I can first change that to a positive exponent by putting the denominator. And then I can evaluate 2 to the fifth. I just keep doubling 2, 4, 8, 16, 32. Now here, this negative exponent goes to not just the 2/3. I could write that as 1 over 2/3. Now it's the positive 2 second power, which is 1 over 4/9, which is 9/4. So the fraction work, where dividing by a fraction is the same as multiplying by a reciprocal. So I kind of think about when I have fractions to a negative exponent, you're really just doing the reciprocal there. So this could have been equivalent to, right away, 3/2 to the second power. So you can flip the fraction. It's the same thing to get rid of the negative exponent. Zero exponent property, kind of already stated this, anything to the 0 power is 1. Be careful, the 0 property here is just that one term. X goes to 0 power, the 3 is in front, so you have 3 times 1, which is 3. So make sure you're aware of what the 0 is the exponent of. In this problem, the 0 is just a power of y. So that one part is 1. So then here we have 3x squared still to the 3rd power, which that 3 goes to everything in there. So this is 3 cubed times x squared cubed. And using our properties, 3 times 3 times 3 are 27. Times x to the 6, we multiply those. The quotient of powers property, where if you're dividing these, you can rewrite it as subtracting. And I can write that a few other ways. Let me show that a little different. 7 to the 11th divided by 7 to the 9th. So this is really means we have 11 sevens up here. That's what that means. On the bottom here, we have 9 sevens down here. So these reduce out. 7 divided by 7 is 1. Those reduce out. And they keep reducing out. But these 9 then reduce out with 9 of these. And I'm left with 2 left over. And so there's more on top. So I have 7 squared would be what's left over, which is 49. So I kind of think what reduces, or 7 to 11, 7 to the 9th is how many 7s we multiply we can reduce. For the next problem, we're starting to combine more. We have different things. If it helps you to break the problem up, so we have, this is part of the problem, times. And then let me put the one to the same variable on the same fraction. So I'm rewriting it a little bit to help me out. So 10 over 2 I know is just 5 times. The second fraction here, the b's in the numerator reduce with the b's in the denominator, but I still have 4 left over. So 3 in the top reduce to 3 at the bottom. So I still have 1 over b to the 4th. And for the m's, I have a negative value here. So if I want to make that become positive, I want to put it in the denominator. So that's the same thing as 1 over m to the 5th. That stays in the denominator times m squared. I move these m to the negative 2 to the denominator to make it positive. So if I multiply there, it's going to be 1 over m to the, add those, because they both have their own m value, it's a base, so 5 plus 2 would be 7. So I'd write the final answer as 5 over b to the 4th times m to the 7th. So this is the last one. Power of a quotient property. So it's similar to the power of a product property, but here we're dividing instead of multiplying. And so just the power goes to everything inside the parenthesis. Almost like common sense for some of these rules. So this is 2 to the 5th over 3 to the 5th. That 5 goes to both of these numbers. So 2 to the 5th, 2, 4, 8, 16, 32. 3 to the 5th is 81. 81 times 3, so 243. Last problem here for the properties. This 3 goes to everything in here. It also goes to this fraction, which means it goes to the denominator as well. So I could write this as negative 2 to the third over 3 cubed times a squared to the third. I'm just showing you how you can raise everything to the power of 3. Now we need to simplify each part of that. So negative 2 to the third, and I should show parentheses here to be mathematically true because the 3 goes to that entire thing. It's all in the parentheses. So negative 2 cubed is still negative 8. 3 cubed, 27. And times we have a squared cubed, which is a to the 6. And then we have x cubed cubed, which is x to the 3 times 3, 9. So that would be the result. The other topic we want to talk about here is scientific notation. So some basic scientific notation. I'm going to fly through this. We should call it a number written in the form of the number c times 10 to the n power, where c is between 1 and 10 and n is an integer. So the number here, c, has to be a number between 1 and 10. N is some integer. It could be positive, negative, whole number. That's what integer is. The x here is really the times. We are multiplying is what that means. It's the only time I really use x for multiplication in the class is scientific notation. And so we have here 7.29 times 10 to the 6. That means we're multiplying by tens, actually 6 tens. And every time you multiply by 10, we move the decimal one spot to the right. So what happens when you multiply by tens? And so 7.29 times 10 to the 6 is the same thing as taking the decimal, we're moving it 6 places to the right, and so we have 7,290,000. If we had a negative value, so let's talk about the negative exponent here. This negative exponent really means 1 over 10 to the 7. So we are actually dividing by tens. That's the math behind the negative exponent. Every time you divide by 10, you actually move the decimal left 1. And so for this problem, 4.5 times 10 to the negative 7, remove the decimal left 7, so we end up with a very small number, 0.00000045. So just how you're moving the decimal depends on the sign and the exponent, sign of the exponent. So scientific notation, we can actually write in scientific notation, go the other way, so 618, and you make that, move the decimal place. Right now it's after the 8. I want to move it so it's between the 6 and 1. So the number in front is going to be 6.18. That's the first step. The next thing is how many spots did I move? 2 spots to the left. So if I want to go backwards, I need to move it back to the right, so it's going to be positive 2. 2.5 is already in scientific notation, but what's the power I can multiply by? It would be 10 to the 0. So I'm only multiplying by 1, so I'm not changing the value of it. For this one, I need to move the decimal spot 1, 2, 3, 4, 5 spots to the right. So it's going to be times 10 to the negative 5. So for that one, you're moving it right 5. The difference of left or right tells you the sign. For this one, it's going to be times 10 to the 8. 3.1 times 10 to the 8th, 8 spots. Where if you're multiplying two scientific notations, you don't have to put them back into standard form. You can just multiply the parts. So do 6 times 2.4, so that's 12 plus 2.4, so 14.4. And then you can also multiply together their powers. 10 to the third times 10 to the fifth is going to be times 10 to the, what's the exponent? We add those, 10 to the 8th. But this one right here is actually not, the answer is not in scientific notation yet. We still need to move the decimal 1 spot to the left to make that number between 1 and 10, so 1.44. Now if we want to move the decimal 1 spot to the left, we need to increase our exponent by 1, so we need to multiply by another 10 to move it back to make it equivalent. So this would be the answer in scientific notation. So the next two problems are similar to the ones we just did, but you have to use some other kind of rules. The 3 goes to everything in here, so apply it to both. And then for C, you're actually dividing, so you divide the numbers and divide the powers. And so I'm going to have you do these two problems for, so you guys going to be on camera? Okay, come here. You gotta wave by. I'm all done, so you gotta wave by. See that little hole right there? That's actually a camera. I'm going to wave hi to it. Say bye. You gotta come over here if you want to be on. Okay, real quick.
Bye.
Maybe I'll find when you're done watching this. Okay.